Let's pick up right where we left off. In the last part of the video, I was saying that two data values with the same z-score are equally extreme, even if they come from different populations. And I want to give you a visual example of what I was talking about. And this example is just imaginary. So I'm just going to be talking about two imaginary classes. We're imagining that two classes just took an exam, and both classes have a mean exam score of 70. Both classes have an average of 70, but the two classes have different standard deviations. Class number 1 has a standard deviation of 2, and class number 2 has a standard deviation of 10. So if you've been following with the other videos, you should already understand that this means that class number 1 has less dispersion, the scores are less spread out, and class number 2 has more dispersion, the exam scores are more spread out. And you can actually see that by looking at these diagrams. So you can see in class number 1 that these scores pretty much all fall between 64 and 76. And in class number 2, they pretty much all fall between 40 and 100, which means that the scores are definitely more spread out in class number 2, which is why they have the bigger standard deviation. But now let's focus on what I really want us to be focusing on here. So let's imagine that a certain person in class number 1 has a score of 74 on the exam, and they have a z-score of +2 because you start at 70 and you go up by 2 and you go up by 2 again. And let's imagine that in class number 2, a certain person has an exam score of 90 and a standard deviation, an exam score of 90 and a z-score of 2, because here you start at 70 and you go up by 10 and you go up by 10 again. And if you look at the position of this person in class number 1, and you look at the position of this person in class number 2, you can see that they're equally extreme because they're at the same position compared to other students. So the percentage of the class that's above this person is actually the same as the percentage of this class that's above this person. The percentage of students in this white area right here is the same as the percentage of the class that's in this white area up here. So these two students have the same standing in their classes compared to other students that they've taken the exam with. So you could say that these two people did equally well on the exam compared to other students in the class, even though their two scores are different. So in this class, well, what I mean is a score of 74 in class 1 and a score of 90 in class 2 are equally good. They're equally well performing because a score because in class number 1,